Question 4 is about polarised light. Actually, quite a discriminating question whenever they ask on polarisation. So if you don't understand polarisation, take the time to learn as much as you can from this question and from reading around it. What's meant by the term plane polarised? Look it up in the book. Draw a diagram. Part B. Describe and explain the effect of rotating a polarising filter. Well, as you rotate the polarising filter, the intensity of the light will vary from a maximum to a minimum because a polarising filter only lets light through oscillating in one plane. Part C. If you have changed the polarisation plane by 90 degrees, then the beetle will do the same. And part D. What would happen to the beetles on nights when the moon is not visible? Well, without the lack of any guidance, they will just wander around in reasonably random directions. There will be no specific guidance for them to tell them which direction to move in. Question 5. It's a potential divider circuit for part A. Part B, it's just the ratio of the resistances and you need to work out how that will divide. The answer is 4 volts. Part C, resistance equals resistivity in ohm meters, which are given in the question, multiplied by length divided by cross-sectional area. Notice in this case they give you one of the figures, 5 centimetres. You need to turn that into meters for the cross-sectional, when you're calculating the cross-sectional area, or else you'll get the wrong answer. The correct answer is 97 to 98 ohms, which is about 100, as they say in the question, but you need to show how you got to the answer of 97 or 98. Part 2 is just a matter of adding resistors in parallel. You should of course remember that resistors in parallel in this case is 1 over R1 plus 1 over R2. If you do that correctly, you will get the answer at 4.8 ohms. When it didn't have the ballast in parallel, the resistance was 5, it's now 4.8. In other words, it's not dropped by very much in this case, so make an intelligent comment about those two values when you're answering part 3 there. Part 4, when a train is on the track, it will short circuit the relay, so that will mean there will be no voltage across it. It will be very small, or pretty much 0. And then part 5, you just need to use this equation again, but this time the resistance R2 is now considerably less, it's 0.5 ohms. You should therefore, in the final part of this question, discover that the total resistance has dropped to 0.45 ohms. Look at the introduction to the question right at the beginning to find out what that means in terms of the colour of the signals. Part 6. Part A, I think, is pretty self-evident, slower. What would need to be measured to make a simple comparison? Think about what you could measure easily about lava moving. Velocity is one that springs to mind. Part C, think about it. Part D, look it up in the book, laminar and turbulent flow. You need to be quite careful with the diagrams when you're copying them out of the book because mark scheme is sometimes quite picky, understandably so, about you understanding the difference between turbulent and laminar flow. And Part E, we're talking about logarithmic scales here. If you're not sure why it is a log scale, look up log scales in your book and see why they're used in this case, and look at the range of values you've got. You've got 10 to the 5 between the two viscosities here, one at 10 to the 3, one times 10 to the 8.